Welcome to the Budget Conscious Astronomer. My name is Jim Craig with Planet of Mystery Productions, and I am the Budget Conscious Astronomer. Uh, One of the things that people don't think about when they're getting ready to do astrophotography, everybody asks, what kind of telescope do I need? What kind of camera do I need? What kind of mount do I need? Do I need a guide camera? Do I need a guide scope? And if so, what kind? Something people don't consider is the software for processing. And there are some great professional packages out there for processing your astrophotos. Even some of the more typical just graphics programs can be used for processing your astrophotos, but they can be expensive. And some of us are on a budget. So we want to find an alternative that makes it more affordable to us. Fortunately, there's a really good package available. It's called Siril. It's based on the old Iris. This actually was originally Iris for Linux, and then they turned it around and made it Siril. And it's no longer just for Linux. It's now available because it's cross compatible for Windows, Linux, and Mac OS. Just whichever version you need for whichever operating system, you download it here. It's at Siril.org. I'll put a link down in the show notes below. The current version is version 1.2.3. I'm not going to be installing it because I do already have it installed. But in the space of an afternoon, I was able to take some images I had and produce this in Siril. Now I'm going to do this as a workflow from beginning to end, assuming that I have all of my images gathered, and I'm going to do it in 5 parts. The first part is converting calibration frames. Don't worry when we get there, I will tell you what those are for. Pre-processing and stacking your light frames. Those are the frames that actually have the items that you want to work with. Then star removal with Starnet. And again, I'll explain what that is and why you do it. Stretching your image out using generalized histogram or generalized hyperbolic stretching, and then bringing out some of the color for saturation. Because, for example, I shoot in very light polluted skies, and a lot of the color gets washed out, and I need to bring that back using saturation. And then finally, since we removed the stars, we're going to put those stars back in with star recomposition. Now, one of the first things I do when I set up my software, by the way, this is not scripted. I've worked on this several times, but this isn't scripted. So if I pause every once in a while, don't worry, I'll get back on track. But I start before I even fire up Siril. I start by making directories and subdirectories. For example, this is Astro Tutorials. And inside this, I have directories, some of which have the stuff stored in it. For example, storage. There's my light frames. Process, that will be for at the end when we're saving our images toward the end. But these directories, lights, darks, dark flats, and flats, those are for the calibration images. Siril will write its own versions of these. It will do some conversion in order to make them usable. These are the directories we're going to store those in. So let's fire up Siril. That's right there. And again, version 1.2.3 is out. It's good software and it keeps getting better. They keep making changes in it all the time that improve it. So one of the first things we do is we need to change our working directory. And to change that working directory, there's a little icon up here that looks like a house. And the one we're going to pick is darks. I did actually already have it picked. And click open. And there's currently nothing in it. So we're going to populate that. By the way, I have a checklist here, so if you hear me rattle a paper or something, that's because I'm marking off my checklist so I don't forget any of the steps along the way. So let's populate this by clicking the little plus icon there. Go to storage, darks, and we're going to select all of those. Control A, add. And dark frames, they're a calibration frame that takes out uh, hot pixels. Because if you look at your images, sometimes you get like a little red dot or a little blue dot. That's a pixel that is stuck in the on position, and there's no way around it. So what we need to do is tell the computer where to find them and compensate for them. My particular camera, I use a ZWO ASI 294MC Pro. It has what's called amp glow. There's a little amplifier inside there, and it causes noise along, sort of a glow along one edge. By using dark frames, I can completely get rid of that. So now that we've got all of these loaded, we need to give this sequence a name, and intuitively, I just call it dark. Now, because Siril is somewhat resource intensive, it likes to use as much of the computer as it can. It makes recording audio when something is going on very choppy. So what I'll do is when I click, I'll be quiet and let the computer do its work until it's done. This first part, however, is really fast. It's done. So we now have a sequence, and it has saved all of those, making new dark frames in a sequence called dark_dart.seq for sequence. So now what we want to do is we want to stack those. Now what we need to do is not weight it. So it's going to stack all 20 of these images. And again, this will take a couple moments. This takes about 4 seconds. So again, I'll click Start Stacking and be quiet. And that's done in actually a little over 3 seconds. So we have now converted our dark frames. The next ones we'll do, we're going to convert our dark flats. And dark flats do correction similar to what the darks do on our light images. It does it to our flat images. So we're going to change to our working directory of dark flats. Again, there's nothing in there. We're going to clear out all of those darks by using the little remove files. It looks like a little left pointing arrow with an X in it. And we'll go into storage, dark flats, Control A and select all of those. We don't want to call that dark. We'll call it dark flat and convert. And this will take a few seconds more because there are more of them. Come over to stacking and do what we did before. Average stacking with rejection, all of this, Windsorized Sigma clipping, all of that. It's ready to go. We hit start stacking. And with that, our dark flats are now calibrated. Or I'm sorry, converted. Now with our flat frames, it gets a little bit more complicated. So let's come up here, go to our flats working directory, clear those out, and populate this with our flats. So go into storage, flats, Control A to select all of those and add those in. Flat, do the conversion. Again, this will be very fast. Now let's make sure that we have our flat.seq. We need to go into calibration. And now it says use bias. What we're going to use is a dark flat. We're going to click there and go into our dark flats. And if we scroll all the way to the bottom, we see one that says dark flat stacked. By the way, you can see there a little glow. That's the amp glow I was talking about, that very slight light area there. See it more, it's easier to see there. And that's going to do cosmetic correction to take out any hot pixels or anything like this. By the way, flats take care of vignetting and dust that might be in your image. It's going to make a pre-processed version, so that's why the prefix PP is there. We're going to hit Start Calibration. Okay, calibration is done. We come over here to do stacking the same way we did before. It's going to stack 30 of them. Should take maybe 4 or 5 seconds. And that's finished. So the first part of what we're doing here, part one, converting calibration frames, is done. Next, we're going to pre-process and stack our light frames. So hang on just a moment. Like we did before, we want to go to a working directory. In this case, it will be lights. Open that. Come over to conversion. Clear that out. Go into our storage area. Grab our lights. Now this will take a long time because there are 300 of these. I'm going to call that sequence light and convert. You can see that took 3 seconds while the others were taking half seconds. It took almost 4 seconds. But our light frames are in. Let's make sure our sequence is there. Light.seq, we are there. Now we'll go to calibration. We don't want to use bias, so let's click that off. We want to use a dark, and we want to use a flat. We're going to go for our calibrated, our stacked dark frames. So we're going to come up here into darks, and there's dark stacked. And then we're going to use our master flat. For that, we're going to come into our flats frames. Scroll down to the bottom, we have that pre-processed, flat stacked, open. Now, another thing we're going to do here is it says debayer before saving. What debayering is it's taking your image, which is actually made up of 3 black and white images. It's got a red, green, and blue. Your camera has filters in that if you're using the one-shot color camera, which is what this tutorial is for. And it says, this channel's red, this channel's green, this channel's blue. Convert that into something the computer can use. So let's click debayer before saving. Another reason we need to do that is registration, which we will do in a moment, does not work unless you're using a debayered image. So we're going to hit start calibration. And this is going to take some time, so I'll probably fast forward through this as well. Okay, that took a little over 30 seconds, and you can actually start to see just a little bit here, some of the image there. We're not going to look at it yet, because the next thing we need to do is registration. And what registration will do is it will look at the stars in the image, and it will align them between images, because your scope is going to shift a little bit, sometimes intentionally through it's called dithering. You want that to happen so your noise doesn't, your signal to noise ratio gets a little bit better when we do all the stacking. So we're going to use global star alignment. Don't worry about the registration channel, any of the transformation. Register all the images from the sequence. And we're going to click Go Register. Okay, that has registered 300 frames. And if you look in our sequence, you're going to see an R for registered, PP for pre-processed light sequence. So the next thing we want to do is we want to stack. We don't want to stack all of the images because some of them just aren't going to look right. So what I generally do is I go with a percentage. And I tell it to do 90% of FWHM, that's full width at half maximum. That's a measurement of how tight your stars are. You want your stars to be small and tight. So with that, we're going to start stacking. And then this will finish part 2 of this tutorial. Okay, between the normalization computation and the actual stacking and saving it, it took a little under 3 minutes for that to happen. Now we actually do have an image over here. I'm going to go from linear to auto stretch. I will warn you, this is not going to be an attractive image, but it will show you that we've got something over there. Yeah, it's kind of ugly. It's because it's not processed yet. But that is the image we are going to work with. So we're going to start this part of it by getting rid of that green. So we come here and click Remove Green Noise, use all of the defaults, apply. And it's got kind of a tan cast to it. We haven't done any color correction or anything to it. So that's actually the next thing we're going to do. Actually, before we go there, we're going to crop this because sometimes you get processing errors across the edges, make some artifacts that we don't want. So just click in the top left. Actually, go outside there. We're going to click in the top left and just drag down, leaving off the edges. Right click and come down to crop. Now we're going to extract the background. You may notice that it's kind of darker here and lighter here. There's actually kind of a circle here. That's an artifact in my telescope, and I can get rid of that. It's because my back focus wasn't set properly. By the way, I've skipped one thing I wanted to talk about. I'll get back to the background removal. This window over here is called a console. This tells you what the computer is doing as it's doing it. And also along here, there's a blue line you see, and it will grow across there. That's sort of a progress meter to let you know how well it's doing. That way you can look and see that it's still moving and that you know your computer hasn't locked up. So the next thing we're going to do is we're going to get rid of that background. And when we get rid of that background, we'll also get rid of a good share of that brown color. So we're going to go to background extraction. And I generally use the default settings here. And what it's going to do is going to make a bunch of little red squares where it's going to sample little pieces of the background. You hear a cat down there. She's a little unhappy because it's just before her dinner time. Don't pay any attention to her. She's not suffering, and she's definitely not starving. So we're first going to compute background. No, I'm sorry. First, we're going to generate. And we want to make sure that the little squares it makes are not on any of the nebulosity or galaxy we want to get out. For example, this little galaxy here. So to get rid of one of these, you click. And if you want to put another one in its place, you left click. To get rid of it, you right click. To put one there, you left click. I know that there's some nebulosity there. That one and that one are a little bit close. It actually did a pretty good job this time. So now we click on Compute Background. And we want our correction to be subtraction. We want it to subtract out all of that background. And this only takes a couple seconds. Actually, I'm going to add some more along the edge here. And decide it. And make sure that you don't put any of these squares on a bright star. Okay. Compute background. And it's done. And you can see it's evened it out and that brown color has gone away. And if you want to compare, here's your original image. You pull down and click on Show Original Image and then go back. Now you want to apply. If you just hit close, all of that work goes away, as I've discovered. So apply, and that's done. Next, we're going to do what's called photometric color calibration. And what that does is it goes onto a database and looks at the stars, knows what colors they're supposed to be, and corrects the color for that. So go to image processing, color calibration, photometric color calibration. Now here you need to know some things about your equipment and about the image. The image is of M51. So we're going to do a search for that. And it's going online looking that up, and it found it. Now, because it was stored in what's called metadata or metadata, depending on how you want to pronounce that, it knows the focal length I was shooting at and the pixel size from my camera. If you don't know that, then look it up on your scope. That also includes if you're using any correctors, field flatteners, anything like that. Make sure that that's calculated in. And the pixel size of your camera. You'll also notice it says flip image if needed. I happen to know that this image is reversed. So click OK. And it's color corrected. And you'll also notice it flipped the image over. So you can hit close. So now you're set to go on to the next step, which is going to be star removal. In order to do star removal, you need a package called Starnet. And Starnet is at starnetastro.com, and it's another piece of open source software. You can download it, and it too, Windows, Mac OS, and Linux. If you already have it, then you'll want to update it. If you don't, you're doing a fresh install, download the install. There are also versions for PixInsight. Don't worry about those if you're using Siril. But once you get it installed, you'll go into your uh, settings menu, go to Preferences, and let me see, where was it? Miscellaneous, I think. Yeah. You'll come down here and you go to your Starnet executable. I've already got it, but I'll show you where it is. Going to go into your C directory, program files, Starnet, and the Starnet plus plus is what you want. Open, apply. Because you want to be able to remove these stars. The reason you want to remove the stars is when you're processing an image, in order to get the spiral arms here bright enough so you can see them or bring out some of that nebulosity, it can cause your stars to be blown out. Like in this image, those stars are just a little bit too much. There are too many of them in this image for my taste. So let's come up into image processing, star processing. And the first thing I do is desaturate the stars. That only takes a second, but that helps calm down the colors of the stars. Next, we're going to go to our processed folder because it's going to write two files. It's going to write one image that has the stars in it and one image that has the galaxies in it. When we want to put those in our processed folder because we will be loading those back in and we want them easy to find. So once again, we go to star processing. Now we're going to click on Starnet star removal. Do a little pre-stretch on the linear image. That makes those stars easier to find. It makes it easier for the algorithm to remove the stars. Want generate star mask. If you don't have that, you won't have stars to put back in. We're not doing a sequence and we don't want to recompose stars on completion yet. So let's just click execute. And this is very computer intensive, and this definitely takes some time. And now we have a starless image to work with. Don't worry, we still have the stars. They're stored in that directory. But this is the image we're going to work with. So this is a good place for me to pause, feed my cat, and then we'll come back and finish up on our image. Well, now that we have a starless image, we can start doing processing using generalized hyperbolic stretch. So first we're going to come over here and we're going to turn off auto stretch, go to linear, and that's the image we have, and that's actually a little bit stretched. Move this over here. And if you look right here, this little thin blue line, that's actually all of the data that the image currently holds. So we're going to zoom in on that. The most it will zoom in is 100%. And that's all of the data right there. And what we need to do is we need to stretch that out to cover that entire histogram. So we're going to start by grabbing an area here. You can either grab an area here or you can click in here. We're going to set the symmetry point. So you can either set the symmetry point by clicking there close to the peak, or you can use the eyedropper and you can see the pretty close numbers there. Then using the stretch factor, we're going to start. We're not going to do this all at once. This is an iterative process. We do it a little bit at a time. And that's not too bad for a first start, but notice that the cores there are a little bit blown out. So we're going to bring up that local stretch intensity to just sort of bring that down a little bit and apply. Let's see if we bring this down to 25%. That's still a bit too much. Let's go 10%. That's not too bad. Okay, we're going to, again, use our selection tool. So click and drag a little area here. Bring that to our symmetry point. And stretch. Maybe a little bit more. And the stretch intensity now is going to actually make that brighter. So in this case, to keep that from blowing out, we'll come down here to highlight protection. And again, it'll help keep that from getting completely blown out. Apply. Now we're going to come to some of this. It looks like nebulosity. It's actually a star cloud. Select there and stretch it out a bit more. The local intensity, highlight protection. Click apply, then we're going to close that. And that's pretty much our image right there. But you'll notice not a lot of color to it. And I happen to know that there's a fair amount of blue. Actually, we're going to bring up the generalized hyperbolic stretch one more time. Zoom that to 1. And what we're going to do is, this background is very gray. I'm going to go up here instead of the generalized hyperbolic transform. I'm going to do linear. Be really careful. We're going to try to move this whole stack over to the left a bit. We don't want to clip off any of the data here. Just bring the black out a little bit and apply. So that's our image pretty much processed. Now let's bring in color saturation. Move that over, zoom in a bit. And I generally take this up all the way the first time. You can see some color has come out. So apply that. And we're going to do it again, maybe not quite as much the second time, because you can, if you take it up all the way, it gets garish and that's a bit too much. Actually, that's not too much because I'm going to take out some of that yellow here. So apply. Then we'll go to color calibration again. Only this time we're going to do the general color calibration. We're going to click manual white balance. Take this down to maybe 0.85. 0.85. We'll do the same with the green. 0.85. And apply. And that will get rid of some of the yellow. And there we go. That is our image properly stretched and color corrected. But it looks a little blurry. So there's one more thing we can do. And that is wavelets transform. This is a true wavelets foundation or transform. And you have to tell it to execute, otherwise it won't do anything. And I generally go to linear rather than the B-spline. And I start by taking that first layer up to maybe like 1.25. And when I hit return, you'll see it makes a little difference. Actually, if you do like 3, that's ridiculous. You don't want to go that far. 5, 1.5 again, it's just a little too much, so 1.25. And the next layer, you go a little bit harder. You can try 2. Too much, so let's try 1.5. And if you want to compare your original image to what you're doing, just click the preview off and back on. Layer 3, I think you can go all the way up to 2. Again, maybe not, maybe 1.75. Layer 2 up to 2.5 maybe. Okay, and apply. So that's our image ready to add the stars in. We need to save it before we do that. Otherwise, everything we've worked on will be lost. So come up here and just click Save. So now it's time to recompose our stars. So do star recomposition. So under Image Processing, Star Processing, Star Recomposition. And we're going to open the image we just saved. So open, and you see here it's starless. That's the exact same image. And now we're going to go and bring in star mask. And you can see a couple of stars have come in, but we need to stretch those. We're going to stretch these a lot the way we stretched the main image. We're just not going to do it as much. There's some more stars. Bring that in and hit apply. Again, we're going to do this iteratively. So a little bit more. And you see, that's too much. So back that off. Apply. And then you go like really stupid and make it really ugly. Or just a little bit. And apply. And close it. And now your image is finished. So the last thing you have to do, you'll notice this Save button up here is grayed out. You have to save it under a new name. So save, and I will save it as M51 Fit. But most paint programs won't do fit programs properly. If I take this into Photoshop or GIMP, which is what I normally use, again, nice open source software, it won't touch it. So we can come up here and just change that file extension to TIFF or PNG or some other supported file and click Save. And what you'll see is that image looks very much like the one I did earlier. The other one I did earlier is maybe a little bit brighter, but it's a matter of personal preference. Now, this image is a bit noisy, so you can take it into some noise reduction software, which is the subject for another video. So in the meantime, this is Jim Craig, the Budget Conscious Astronomer, hoping that you try some of these techniques. Let me know what you think in the comments below. If you like what you saw here, give me a thumbs up. Consider subscribing. And if you do have a link to something that you processed using Siril, let me know, because I'd really like to see what you're working on.